Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science, just like I did. And today we're doing another example from the LeetCode series, more specifically the one called +1. It's an array type problem in the easy category. So let's go to it. Basically, what's going through here is that as our input, we've got an array. That array represents a number. So if you've got 1, 2, 3, they really mean 123. And what we want to be doing is to increment that by 1. So you wouldn't be returning 124, the number, but rather the actual array. And that's why we see that the output here is an array. Now, it seems very simple, right? Especially the examples we're seeing here. Okay, right-hand side, always add a 1 and you're done. And actually, when I was starting, I even put like a little specific if statement at the beginning to kind of return that from the get-go, but the ultimate thing I have takes care of that as well. So that got me thinking, all right, what could go wrong? This one clearly still fine. And then this one is where things start getting funny, i.e. the biggest problematic is really there's going to be some times where we're going to need to extend the array. Now the other question to ask is how much are we extending the array, because that's super important in general, space complexity and just how much memory you're using and things like that. So in this particular case, I think my little aha moment as I was playing with this, and I thought, oh, this is also going to be chaotic, but actually not at all, because the right-hand most number is 0, so it's just going to give you 1 and nothing is happening. So that gets you thinking, all right, well, clearly this is the absolute worst case scenario, because it's like a little domino effect where this one affects the next one, affects the next one, and you get that little expansion. So really, it actually just matters what the right-hand side has. Because as soon as that's not a 9, then you're good to go. And then if it's a 9, then you just start almost like put a new little anchor, forget about this part, but look onwards and see if that's a 9. So they can almost be seen as kind of smaller and smaller subarrays that you're looking at whenever you have these sort of bizarre 9-heavy arrays. I think really that says it all. I think that's the biggest thing to keep in mind. I did add this, which I'm going with this assumption, but if this was like an interview or something, that's, I think, a good question to ask. Would you have leading zeros? The good thing that we know is you're definitely not going to have like a 10 or an 11 as a piece of the array, but rather only numbers between 0 and 9, but worth checking if this would ever exist. But technically, because 1, it's not empty, so that's one thing to keep in mind. But 2, it is supposed to represent a non-negative, like no negative sign situation here. I believe, if you want a 7, then you represent it this way. So this is a safe one that we don't need to worry about, in my opinion. Okay, and then the way I go about it is looping backwards. So I think it's pretty self-explanatory, but let's do a little bit of sort of penciling in here. So because we said that the rightmost element is really the one that's going to determine everything, especially in the particular case of this one. So you definitely want to make sure you're starting on this side. I always like using this for looping with Python in particular backwards. And basically this is -1 because you're going to start in this particular case, for example, from index, let's look at it like this, 0, 1, 2. So you're going to be starting, the length is 3 minus 1 gives you a 2, so you're good to go. And then you're going backwards one by one. So you want to make sure, because this is not inclusive, you don't stop at 0, because then you're not going to encounter this one. It's going to sort of stop and ignore 0. You want to make sure there's a -1 there. All right, and then here, I mean, we could do like an if else or something like that. That's not a big deal, at least in my opinion, but I'm always happy to learn. So here, basically, I always like starting with the things that's going to give us a return so that we exit, sooner than later. And this is sort of everything I was talking about before, kind of like the very happy land of, well, if it's not a 9, not my problem, like I'm good to go. And what does good to go mean is, I'm going to change my 3 to my 4, and that's it. That's like the same position within the array, in this case 2, in this case 2. So that's what's happening here. I make the little incrementation and then provide back the same array, right? That way you're not using any extra space, but rather the thing itself that was part of your input. Okay, so then there's that, and this is the like not so happy land when it's actually equal to a 9. Is what we're seeing here. No, it's a little covered. There, now you're saying, all right, well, what I'm going to do, and this one I thought for like a couple of seconds, do I need to do a lot more over here? And really not much, no, because if you look at the example that we had here, I mean, there's nothing you could do when you're still stuck over here. Everything is to, like the whole domino effect is as you're looping, which you're already going to be doing. So no duplication. So the only thing you could do is say, all right, well, that's definitely going to be a 0. And let's see what happens next when we get to it. Like, let's, what do you call it? Decide once we cross that bridge. So that's what's happening. Like the only thing I do is that. However, the one thing you do need to keep in mind is if I get to the end, i.e., like I call it here, the left most part of the array, then this is finally, that big situation that we were talking about, keep in mind that you need to extend an array as a possibility, and that's finally when you say, okay, great, I already changed it to a 0, so here we would have another 0, and now just do my little extension, and that's it. Now you can kind of also return the lovely, that's a heart, digits that has all the modifications within it already. So that's pretty much it for this one, and therefore, your time complexity is still O of n, and actually it might even be, well, it might be shorter, but asymptotically, we should say O of n, because you could have, again, that bad example and you're indeed looping through, but otherwise you might exit fairly quickly. Even if you had, a million here, or the longest possible, whatever they give us here, then still that's actually going to be very quick. In and out, you change your last digit and you're done. So that's that. I hope that was interesting. Please do add any questions or comments below. And if you like it, I'd love it if you subscribe. See you next time. Bye-bye.